Okay, so now that we have Deno set up, we've got Zed set up, now we can go to the Advent of Code website and start tackling some of the challenges. So let's open up Chrome again. And I think I can close this. I'll keep Deno open, and then we can do the Advent of Code 2024, and then we can go into the first question. So I'm going to bring this up for you guys to read, and I might actually get ChatGPT to read it out for you guys because I'm not good at reading aloud. So here we go.
Day 1. Historian Hysteria. The chief historian is always present for the big Christmas sleigh launch, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. As each location is checked, they will mark it on their list with a star. They figure the chief historian must be in one of the first 50 places they'll look, so in order to save Christmas, you need to help them get 50 stars on their list before Santa takes off on December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. You haven't even left yet, and the group of elvish senior historians has already hit a problem. Their list of locations to check is currently empty. Eventually, someone decides that the best place to check first would be the chief historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search? Throughout the chief's office, the historically significant locations are listed not by name, but by a unique number called the location ID. To make sure they don't miss anything, the historians split into 2 groups, each searching the office and trying to create their own complete list of location IDs. There's just one problem. By holding the 2 lists up side by side, your puzzle input, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists? Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list, then the second smallest left number with the second smallest right number, and so on. Within each pair, figure out how far apart the 2 numbers are. You'll need to add up all of those distances. For example, if you pair up a 3 from the left list with a 7 from the right list, the distance apart is 4. If you pair up a 9 with a 3, the distance apart is 6. In the example list above, the pairs and distances would be as follows. The smallest number in the left list is 1, and the smallest number in the right list is 3. The distance between them is 2. The second smallest number in the left list is 2, and the second smallest number in the right list is another 3. The distance between them is 1. The third smallest number in both lists is 3, so the distance between them is 0. The next numbers to pair up are 3 and 4, a distance of 1. The fifth smallest numbers in each list are 3 and 5, a distance of 2, 6. Finally, the largest number in the left list is 4, while the largest number in the right list is 9. These are a distance 5 apart. To find the total distance between the left list and the right list, add up the distances between all of the pairs you found. In the example above, this is 2 plus 1 plus 0 plus 1 plus 2 plus 5. The total distance of 11. Your actual left and right lists contain many location IDs. What is the total distance between your lists?
Okay, so here's the plan to solve this problem. We take our list and we split it in the left and right columns. Then we need to sort each list in ascending order. We then need to pair up each item in the list to form pairs. Then we need to start calculating the distance between each pair. And finally, we need to take the sum of all the distances to get our answer. Cool, so now that we have a plan, let's go and code it. Okay, so the first thing we're going to do is we're going to create a new folder. And then inside of our folder, we're going to create a day 1 TypeScript file. And this is where we're going to write our code. Next, we're going to create a function called day1, and we're going to write the logic to solve the problem inside of this function. Now we're going to write out the steps that we need to follow in order to solve this problem. The first thing we need to do is we need to parse the input into two lists, namely the left list and the right list. We're going to use the string split function to split the text file into rows by splitting on the new line character. We're then going to create a for loop so we can loop through each line and then isolate the left and the right character that we need to put into the left list and the right list. Now inside of the for loop, we can start working with each line to try and isolate the left character and the right character. We can do this by also using the string split function. We can split on the 3 spaces between the 2 characters, and then we can take the left character and the right character and put them inside of their respective lists. Now that we have the individual lists, we can sort them in ascending order. We can do this just by calling the sort function, which by default sorts the list in ascending order. Now that both lists are sorted, we're going to create another for loop so we can iterate over each individual item in one of the lists and then start creating pairs so we can calculate the distance between each pair. We can use the iterator j to access the left digit and the right digit inside of the lists, and then we can form a pair so we can calculate the distance. It's important to remember that we need to use the absolute function here so that we always calculate a positive number when determining the distance between the 2 values. And finally, we can add the distance to our sum variable by using the shorthand notation plus equals. This will ensure that we sum all of the distances for each iteration. Ultimately, this will give us our answer. I'm going to add a few console logs just to give us some information while we run the function, and then we'll see what our answer is when we give it the example input. I had to figure out how to use Deno to read in a text file, and by using this example, we could simply read in the text file and convert it into a string text variable. We can then pass in this text variable into our day1 function. We need to make sure to trim the text input as well, because Zed really likes to add a new line whenever you save a text file. I don't really like that personally, but this is just the way Zed works. And then finally we can run the function to see if we can get our expected answer. And yes, we can see that our expected answer is 11, and we can see all of our lists, the sorting, and everything seems to be working fine. So now let's take our input that we got from the Advent of Code challenge and paste it in here and run the function again, see if we can get an answer for our problem. Cool, so that's our answer. Let's see if it works. Okay, so let's go back to the Advent of Code challenge, enter our answer, and yes, we did it. We got our first golden star. We solved our first puzzle for the Advent of Code adventure. Okay, so I'd like to give you some of my first impressions about using Zed. To be honest, I'm not sure if I'm a fan. Some of the basic functions that I use in other IDEs like WebStorm is really missing, and it's making the coding experience a bit more difficult than I would have liked. For example, even writing something simple as console.log. I was expecting the log part to kind of have auto-completion just to tell me, what functions are available inside of console. So console.warn, console.error, or console.table, for example. I would have expected those to pop up and a little bit of documentation to show. Maybe that is something that you can configure Zed to do, but to be honest, I don't have all the time in the world to go and configure my Zed text editor to give me all of the tools I need. I feel like it's almost like NeoVim, where you need to really know what you're doing and configure it to your heart's content. So it's a double-edged sword. It's really configurable, it's really fast, it's really nice in that aspect. You can set up the LSPs and code highlighting and language servers exactly how you want to set it up. But for me, I like to have at least something basic out of the box. And I just feel like Zed doesn't really offer what I like to see inside of a text editor. So for any of the following Advent of Code challenges, I think I might actually switch back to WebStorm just to give myself a bit more of a pleasing experience when trying to solve some of these questions. So I'm going to leave it there for this video. I know we've unlocked a part 2 to day 1's challenge, but I don't want to make these videos too long, so I'm going to switch over to WebStorm and then we can tackle part 2 together in the next video.